Let's have some fun. In this lesson, I want to show you how to pop up a window and draw things on it. In an earlier lesson, we painted some words on the screen, but this time we're going to draw some pictures. These are going to be simple squares and rectangles, but we'll be able to cover the fundamentals for drawing stuff. This file contains two classes. The overall structure of the program is the same as it was when we were drawing text in a window. That is, the DrawSquares class extends the Frame class so it can create a window in which to display components. The main method does nothing more than create a DrawSquares object which creates the window. The constructor begins by enabling events so we'll be able to close the window. Then a squares object is constructed and added to the window. The pack method sizes everything, and the show method displays the window. Just as we did when we were displaying text, the squares class extends the canvas object, and the actual graphics are rendered inside the paint method. The graphics object has some methods that can be used to draw simple shapes, and DrawRect is one of those methods. The first two numbers specify the X and the Y positions of the upper left-hand corner of the rectangle being displayed. The next value is the width of the rectangle, and the last value is the height of the rectangle. Now, in this example, the heights and widths are equal, so that means the program will draw squares. They're all different sizes, and the upper left-hand corners of them are positioned so they will appear inside one another. Notice that the squares class is not defined as public. That means it can be in a source file with a name that is something other than the name of the class, but it won't be possible to access the class from anything outside this directory. That's okay, though, because we only want to use it in another class inside this same file. Notice that the DrawSquares class is declared as public. That means it must be in a file named drawsquares.java, and we'll be able to access the class file from anywhere. This isn't strictly required when we're just going to execute its main method from inside the same directory like we're going to do, but it's a good policy to declare things public because we might want to use them from somewhere else later on. Also notice, the import statements for both classes can all be put at the top of the source file. That's because it's only the compiler that needs them, and it reads the source file and memorizes them when you compile the program. Then they're thrown away because they're not needed anymore. Anyway, all that's left to do is compile the program and run it. This command compiles both classes, and each class is stored in its own class file. If we had 20 different classes defined in the same source file, each one of them would have created its own class file when it was compiled. The names of the class files are important because that's how Java locates the classes that your program needs when it runs. And here we have the class file showing the 3 squares that your class draws when it runs. When we ran DrawSquares, it found that it needed the class named squares, so it looked in the current directory for the file named squares.class and found it.